I will be presenting the introductions of our study title, Reflective Concrete as a Sustainable Construction Material for Heat Reduction. Rapid urbanizations and climate change have caused temperature in cities to rise. Natural surfaces are being replaced by buildings, roads, and pavement, creating what is known as the urban heat island. Conventional construction material absorbs and stores heat, leading to higher energy consumptions and increased greenhouse gas emissions. Therefore, sustainable materials are needed to reduce heat assumptions and improve thermal performance. What is reflective concrete? Reflective concrete is a type of concrete that reflects more sunlight compared to conventional concrete. Its effectiveness is measured by its solar reflectance, also known as albedo. It can be produced using light-colored cement, reflective aggregate, special surface treatments, or reflective coatings. These modifications help reduce heat absorptions and keep the surface cooler under the solar exposure. The objectives of this study are to provide an overview of reflective concrete, evaluate its thermal performance, identify its benefits, investigate its applications in urban infrastructure, and review recent research, developments, and future perspectives in reducing the urban heat island effect and improving energy efficiency.
For methodology, first, research method. A literature review approach was used, gathering and comparing information from existing published studies instead of conducting lab experiment. Second, sources. Information was collected from academic database like Science Direct and Google Scholar and credible institutional sites such as Cool Roof Rating Council. And third, selection criteria. Only peer-reviewed and credible resources were used, mostly published between 2019 to 2025, and directly related to reflective concrete material or performance. And lastly, data analysis. Information was organized by teams like materials, thermal performance, and application to identify patterns and compare findings across the studies.
Now, let's talk about our findings from our literature review. First, let's look at how reflective concrete works. The working principle is quite simple. When sunlight reaches the surface of the reflective concrete, a larger amount of the solar radiation is reflected back into the atmosphere instead of being absorbed. As a result, less heat is stored inside the concrete, which helps reduce the surface temperature and minimize heat transfer to the surrounding environment. According to several studies, this contributes to cooler urban environments and improve the overall thermal performance of buildings and pavements. Now, let's move on to the materials used in reflective concrete. Based on the literature review, researchers have used several reflective materials to improve the performance of concrete. These include titanium dioxide, white pigments, calcium carbonate, fly ash, slag, recycled glass, and zinc oxide. Among these materials, slag and nano titanium dioxide have shown excellent performance because they not only improve the solar reflectance of concrete, but also maintain its mechanical strength. More recent studies have also introduced advanced materials such as silica aerogel and reflective coating systems to further improve thermal insulation and heat reflective properties. Finally, the performance of reflective concrete depends on several factors. These include the type of cement, aggregate, curing method, surface color, and environmental exposure. For example, one study reported that moist curing can improve the solar reflectance of concrete, while another study found that weathering and dirt accumulation may also gradually reduce its reflectivity over time. Overall, reflective concrete has many practical applications. It can be used for roads, pavements, sidewalks, parking areas, roofs, and other urban infrastructure that are continuously exposed to sunlight. Besides reducing heat absorption, reflective concrete also improves energy efficiency, reduce cooling demand, and support sustainable urban development. Now that we have discussed the overview of reflective concrete, let's talk about thermal performance and energy saving potential based on the findings from the reviewed literature. Overall, the reviewed studies showed that reflective concrete performs better than conventional concrete because it reflects more solar radiation, absorbs less heat, and helps improve energy efficiency. Overall, the studies reported surface temperature reductions ranging from approximately 11 to 20 degrees Celsius compared with conventional concrete. Although both reflective coatings and reflective pigments successfully reduce surface temperatures, coating systems generally achieve greater cooling because they combine heat reflection with thermal insulation. In contrast, reflective pigments mainly improve surface reflectivity while also providing additional benefits such as water repellency and durability. Next is solar reflectance or albedo. Solar reflectance refers to the ability of concrete to reflect sunlight instead of absorbing it as heat. The reviewed studies showed that different methods, including moist curing, slag replacement, and the addition of nano titanium dioxide, were effective in improving solar reflectance. However, the findings also showed some differences. Compared with curing methods alone, modifying the concrete mix by incorporating slag and nano titanium dioxide produced greater improvement in solar reflectance, while still maintaining good mechanical strength. This suggests that material selection has a greater influence on a long-term thermal performance than relying on construction practices. Besides thermal performance, reflective concrete also offers significant energy saving potential. Since less heat is absorbed by the concrete surface, less heat is transferred into nearby buildings. This reduces the need for air conditioning and lowers electricity consumption, especially in hot climates. In addition, high albedo concrete pavements help reduce heat accumulation in urban areas, which contributes to mitigating the urban heat island effect. Compared with studies that mainly focus on improving material properties, research on high albedo pavements highlighted broader environmental benefits because they not only reduce cooling energy demand, but also improve the thermal environment of surrounding urban areas. Now, let's talk about several factors that influence the overall performance of reflective concrete. Although all of the reviewed studies reported positive results, the level of improvement depended on factors such as the materials used, concrete mix design, curing method, and environmental conditions. Overall, the literature suggests that no single material or technique is the best solution for every situation. Instead, combining suitable materials with proper curing methods and appropriate construction practices provides the most effective way to improve the thermal performance of reflective concrete. In conclusion, the reviewed studies consistently demonstrate that reflective concrete provides clear advantages over conventional concrete. It not only reduces heat absorption and lowers surface temperatures, but also improves solar reflectance, reduces cooling energy demand, and supports sustainable urban development. Therefore, reflective concrete has strong potential to become an important material for future energy-efficient infrastructure.
For our findings, I will be discussing the impacts and applications of reflective concrete. Starting with energy and the environment, the biggest advantage of reflective concrete is its ability to bounce solar heat away from the building. This drastically lowers the cooling load, meaning we use far less energy for air conditioning. It also improves lighting efficiency. Because the surface is brighter, it reflects light better, which means we can actually reduce the number of artificial lights we leave on at night. Environmentally, this is a great tool for fighting the urban heat island effect. By keeping pavements and roofs cooler, the overall temperature of the city drops. Finally, because we are using less electricity for cooling, we are indirectly lowering greenhouse gas emissions from power plants, plus concrete is 100% recyclable. See immediate utility savings due to those lower electricity bills. It is also highly cost efficient over its life cycle. Reflective concrete can easily last over 30 years and requires far less maintenance than something like traditional asphalt. For society, this translates to better thermal comfort. Outdoor pedestrian spaces and indoor rooms simply feel cooler and more comfortable. It also enhances public safety. A brighter reflective surface means much better visibility at night for both drivers and pedestrians, which can help reduce accidents. How does it compare to what we currently use? The key difference is the albedo or solar reflectance. Reflective concrete bounces most solar radiation back, whereas traditional asphalt absorbs almost all of it, and standard dark concrete absorbs a moderate amount. Because of this, reflective concrete stays significantly cooler under direct sunlight. We all know how extremely hot asphalt gets in the middle of the day. In terms of energy efficiency and nighttime visibility, reflective concrete outperforms the alternative by lowering HVAC loads and amplifying street lights. And while asphalt needs frequent patching and resurfacing, reflective concrete gives us a 30+ year lifespan with minimal upkeep. Looking at our local context, Malaysia's tropical climate, with its intense sun and year-round heat, makes it the perfect place to adopt this technology. Currently, we mostly see this concept applied as heat-reflective roof coatings. Many commercial buildings have flat bare concrete roofs, and developers apply specialized polyurethane waterproofing paints to artificially raise the albedo and reflect heat. We also see it in industrial flooring. Many large factories and warehouses in Selangor and Johor use polished, light-colored concretes to maximize natural lighting and keep the factory floor cooler for workers. There is a huge potential to expand this in Malaysia. First, we could replace traditional dark asphalt with reflective concrete for urban pavements and roadways in dense cities like Kuala Lumpur to directly lower street-level heat. Second, developers could use high albedo concrete to easily meet their Green Building Index or GBI sustainability targets for new projects. Lastly, we could use precast reflective concrete pavers on the recreational podiums of high-rise condominiums. This will act as a thermal barrier, stopping the sun's heat from baking the residential units right below the deck. That covers the benefits and local application. I will now pass the presentation to my groupmate for the next section.
For future trends, recent development, researchers are now exploring radiative cooling, where the material not only reflects sunlight but also release the small amount of heat it absorbs back into the sky. This builds on materials already discussed earlier, which is nano-titanium dioxide and slag, but combine them with new methods to manage heat more completely, and it is just not reflect it. And for the future trends, radiative cooling technology has already been tested on railroad, showing better cooling performance than conventional reflective coating alone. And reflective concrete is expected to move from small lab tests toward large-scale use in road, pavement, and city infrastructure as urban heat continue to rise.
Discussions. First, reflective concrete shows great potential as a sustainable construction material for reducing heat buildup in urban areas. Compared to conventional concrete and asphalt pavement, reflective concrete has a higher ability to reflect incoming solar radiations. As a result, less heat is absorbed by the surface, leading to lower surface temperatures. These reductions in temperature can help mitigate the urban heat island or UHI effect, where urban areas become significantly warmer than their surrounding environments due to heat-absorbing material and dense development. The performance of relative concrete depends on the material and technologies used in its productions. For example, reflective coating, slag, and nano-titanium dioxide can improve concrete ability to reflect sunlight. This material enhances reflective durability while maintaining the structural strength and resilience of the concrete. Additionally, new technologies like radioactive cooling have shown promising results. These technologies allow concrete surfaces to release heat more efficiently into the atmosphere, thereby boosting their cooling performance. Beyond reducing surface temperature, reflective concrete also offers several environmental benefits. Lower surface temperatures reduce the amount of heat transferred to nearby buildings. This can decrease the demand for air conditioning, leading to lower electricity consumptions and energy costs. Furthermore, the use of supplementary materials such as a slag can reduce the amount of cement required in concrete productions. Since cement manufacturing is associated with significant carbon emissions, reducing cement consumptions can contribute to the more sustainable and environmentally friendly construction industry. In Malaysia, reflective concrete has strong potential due to the country's hot and humid tropical climate. It can be applied in road, pavement, parking areas, and Green Building Index or GBI projects. Its implementations can improve outdoor thermal comfort while supporting sustainable urban development initiatives. However, before large-scale adoptions can take place, further research is needed to evaluate factors such as long-term durability, maintenance requirements, weather resistance, and overall cost-effectiveness under local conditions. In conclusions, reflective concrete is a promising sustainable material that helps reduce heat absorption and keep urban surface cooler. Its improved thermal performance can enhance energy efficiency, reduce cooling demands, and improve thermal comfort. Due to Malaysia's hot and humid climate, reflective concrete has a strong potential for use in road, pavement, parking area, and other urban infrastructures. Overall, window adoptions of reflective concrete can contribute to more sustainable and energy efficient and climate resilient cities.